seminal algorithm, very important algorithm that was developed called the Viola-Jones. And it was important because it made face detection accessible. It made it cheap and easy to do. So you could take what all of these companies were struggling to do before, you put it on a very small computer. It didn't need a lot of computational resources. You dropped the bar to entry of using it, and you dropped the cost. And that meant more people can do face detection. Today it's on all of your phones, it's on the social networks that are using face recognition, and face detection is ubiquitous. But looking back to 2001, this is the breaking point at which face detection became doable for everyone. So what you see here is a very slowed down version of the way this algorithm works. And it reads an image kind of literally like a book from left to right, scans the pixels, and then analyzes the pixels within that red square. And then if you can see the very light red squares, it's trying to create a confidence score. So you have to have just enough of those red squares overlapping to confirm that it is a face. That algorithm also allowed the localization of eyes and the mouth. So at this point, in 2001, with a very cheap computer, with a free algorithm, you can isolate someone's face, you can isolate their eyes, and you can isolate their mouth. But this tends to be, I would say, a kind of odd way of looking at someone. We look at each other here, and it's a human-to-human scale. When you start drawing boxes on people's face, when you start labeling them, turning them into data points like that camera in the beginning, then you move into a different way of looking at people. And it's what Paul Virilio calls the logistics of military perception. So now that we're using what I call kind of the fallout of this military growth in biometric industry, we're beginning to see with tools that were originally developed for military capabilities. So this next section gets into more of the current stuff, which I think will be more interesting. So these are the tools that are being actively developed, deployed, but they're not by the government anymore. These are, what happened is face recognition was only the tip of the iceberg. The funding that went into these programs from DARPA, from IARPA, from governments all over the world who wanted to be able to harness the power of visual images, set into motion these logistics of military perception. But what we ended up with now is not just being able to look at somebody's face and use that as an index to understand their identity, but it's a way of analyzing everything in that image. And to begin, we can look at, so instead of just reading the exterior, looking at your identity, this facial expression analysis tries to read you from the inside. And that sounds creepy, and I think it is. But it tries to read your emotional state. It tries to read what you're thinking, the mood that you're in. And the other thing that happened is in the mid-90s, when I talked about that ferret data set, that was 13,000 people. And that was a lot of images at the time. And there's another data set called LFW. It's not important what the data sets are called, but then if you compare the government-produced data sets from the 90s to the corporate-produced, well, actually user-generated data sets from today, look at the number from Google in the bottom right. And so we've gone from 13,000 images with 5,000 people to 100 to 200 million. Nobody even knows at this point, it's just in the hundreds of millions, with 8 million different people How do you know if you're one of those people? There's really no way of finding out. Facebook claims to have 4,000 people, which I just don't believe. Facebook is the single largest repository of images in the world. MSFT is Microsoft, and this chart is from a paper that was released by Microsoft. They wanted to create a data set that was open to researchers. So they created a public data set of about 10 million images with 100,000 people. But who are these people? Is it you? Is it me? You could probably find out. They release all the URLs for the images, and most of them are tagged with a Creative Commons license. I think this brings up an interesting point that when you post an image online, you don't know what researcher is going to find that useful in 10 years. You don't know what kind of algorithms, what kind of robots will be looking at that image, or how they'll be using it, what kind of value, what new insights could be extracted from that image in 5, 10 years of time. So if we want to think about photography today, this is another example of what a camera looks like. It has wheels, and it's used by the police. In the same way that photography was originally used to identify criminals. But this is in Shenzhen, in China, and it's a bot that roams the airport, just sucking up people's faces and recognizing. So instead of that cute little camera with the LEDs spinning, which I would definitely favor, instead of this thing roaming around, God knows what it's doing. But now we can see, going back to that chart that I mentioned, with the relationship of corporations playing a larger role in the development of these facial analysis technologies. We can see a very clear example of that partnership from one of the documents that was released by Edward Snowden. And that document says the NSA relies in part on commercially available facial recognition technology from a company called PitPat, which is owned by Google. And Google has given the United States government a blanket license to use their software for whatever they want. So NSA, according to the documents, intercepts about 50,000 images a day, and I've heard that's a very low reported number. It may actually be a lot higher. But the way that these intercepted images for intelligence purposes are being analyzed is from software from Google. And so we have this technology that was originally designed to locate enemy combatants. Now it's being used to identify and track consumers through, you'll never guess, email marketing. Email marketing and facial recognition are not apparent, the relationship between these in the beginning. But if you're an email marketer, you might be able to figure it out. And the reason is that email marketers are bothered when people pay for things in cash, because cash is not a trackable element. So if you go to the store and you buy something with a credit card, that's tracked. That information then goes to a data broker, and that can be used to deliver you coupons. This is how it works. So email marketers are very excited about facial recognition because now when you walk into a store, you can pay with cash and they can still know who you are and they can still send you that coupon to your inbox. That was from the beginning of 2016.